Miklos Fodor presenting the rapid repeated restructuring paradigm. In this chapter, our main topic will be what we are calling random. The paradigm's longer name, if I could choose it, is not only rapid, repeated, but also random restructuring. So it's a key issue to define carefully and precisely. What do I mean by random? We might all know that random is a mathematics notion, very well defined, very accurately defined. You can look up in Wikipedia. But mathematics is only one point of view. It's only one model of the physical world, and it's only one tool to describe the universe and its rules. Even if it's a very accurate one, and I'm deeply respecting it, the biology and the living systems theory is something that can add precious aspects to what mathematics says about what is random. In order to understand what is random, I have to go back to the nestedness of the living systems, and to that important key idea that each living system has its own perspective. So you have already seen this drawing of mine of having a system built of subsystems, and these subsystems is also built by smaller systems, or not smaller, but building systems, subsystems, and this one, this small subsystem has a completely different representation of its environment than, say, this red one. And it's also obvious that a higher level system can be even more, or it has a different representation. The representations are due to the sensors, what type of data are these systems able to process, and of course their internal structure. So this subsystem, or this system's internal structure depends on how its subsystems are linked. Say something like this. When we are talking about restructuring, then we mean the situation when these links change, and say this different pattern of links, or this different setup appears. So that's restructuring. Yeah, something like this. So this is rapidly changing, and here we come to the other adjective or word in our paradigm's title. What is our purpose is to explain what is random. These changes within this light green system these restructurings from external point of view, from this red system's point of view, can be seen as random, as something that is very different, very difficult to describe. Random, as I know, I'm not a mathematician, but as I know, random means for mathematics that you cannot find the function that describes a random number. Sorry. Okay, I didn't find the word series, so or sequence. So so the random is treated a function in mathematics where the series or the sequence of a number cannot be defined by one function, or there are maybe even more accurate criteria what this function has to fulfill. But I'm not saying that there is something supernatural in this within a system that could set a randomness. A randomness usually is connected to a random number generator. At least in computers, there is a function, or it uses noises or different changes that are very hard to predict, and you can using this very changing and unpredictable inputs to set random numbers, for example in Excel or different programming languages. I'm not saying that there is an external agent, somebody here who is generating random numbers, and based on those numbers these links are created. No, instead of this, I'm saying that it's the laws of universe, the quantum mechanics, the laws of physics, chemistry, and so on. So the only reason why we see them as something unpredictable, and why we are saying that it's random, is because they are much or many levels lower happen or have these laws, their effects, the universe laws effects. So if this this very ugly color system, from this ugly color system's point of view, what happens in this blue system's internal structure is so many levels away that is seen as unpredictable. Even though if we could zoom this blue one, we could see the same issue as many levels above. So we could see also systems or subsystems of this tiny small one, and the laws of universe, the universal laws are setting that now these links should appear, or completely different ones, say. And instead of So instead of an external agent that is generating the random numbers or generating the which link should be created, we can say that the laws of the universe are all those laws that the science is trying to describe. So there is no metaphysics, nothing strange in it. That's a different issue that, as we discussed in the very first chapter, that the laws of universe are seen by religious people as God, and the universe itself as God, and their rules as the rules of God. So when somebody wins on the lottery, cannot say why did he win. So he said he can say he has two options. Option one is to say the laws of universe, the particle physics, the atomic physics rules that have come together when the lottery was the lottery number were chosen. That's one reason that the laws of physics made him billionaire. The other reason can be, and we can say option number two. It's much more simple, saying God helped me to become a millionaire. Our statement is that these two things are the same. It's just a nominal issue. So what you are calling what? So are you calling this very complex totality of rules and the universe itself God, or you are calling just universe and just rules? So that's how I approach randomness, and how I approach restructuring itself. The repeated, I think it's the easiest part of the title of this paradigm, is that in order to make the information flow through the system, there are, out of say hundreds of thousands of different setups within a system, there is only one or two that produces relevant output from the super system's point of view. And to reach this, you are increasing your chances by adding more and more setups, and the setup that will work is conserved. So of adding your chances means repeating this restructuring process. It's like if you want to throw a 6 with a dice, and you have the chance to throw it 10 times. Of course you won't say that you want to throw once, and if that's 2, the dice shows 2, then you were losing. If out of 10, of course, it's 10 times as much a chance to throw a 6. Thank you very much for the attention.